Good evening everyone, myself Gautam Sharma. I welcome you all in a Sapiens Education. Today I am going to discuss about the Ncert solution and this is chapter 12, class 12 physics. So let's go for this one. So there is a question that 4-point charges QA, QB. There is a 4-point charges. Let us suppose this is QA, QB, QC and QD are located at the corners of the square side ABCD of a side 10 centimeter. What is the force on the charge of 1 coulomb placed at the center of the square? So let us suppose we need to draw the square first of all. So let us suppose we can draw the square here. So this is a square and there let us suppose there is a charge QA and this is equal to 2 microcoulomb, and there is a charge QB and it is equal to minus 5 microcoulomb, and there is a charge QC which is equal to 2 microcoulomb, and there is a charge QD and which is equal to minus 5 microcoulomb. Now there is a center, so when we match this center, so this is the center of the square will be at this point, so this is the center of a square, right? And the charge at the placed at this one, that is QO, is equal to 1 microcoulomb, right? Now we need to find that how much net force is acting on this charge, right? So this is, suppose this is side A, B, C, D. Now what they have provided, AB is equal to CD is equal to BC is equal to AD, and also BD is equal to AC, that is equal to diagonal, and this sides are 10 centimeter and diagonal will be definitely root 2 into 10 centimeter. So we have this one. So it means all the distance that is this distance, if you talk about this distance, let us suppose this distance, if we talk about this distance, so all are equal, like AO is equal to OB is equal to OC is equal to OD, so all are equal at a equal distance. Now charge or a force on O due to A is equal to what? KQ1 Q2 by KQ1 Q2 by R square. Now the thing is that the force acting, so since it is your positive charge and positive charge, so what will happen? Repulsion will happen. So this side there will be a force which will be acting, and if you talk about this one QC charge, so the force on a QA due to QC will be acting in this direction, right? So equal amount of force, equal and magnitude and opposite in direction force is acting. Why I am telling equal and opposite? So if you observe this one, so this is C, 2 microcoulomb and 1 microcoulomb. If you put this one, so you will get force on a charge Q in this direction. Now if you talk about QC, so similar charges are placed, so equal and opposite force will be applied. Equal and opposite force will be applied. Force will be applied on charge Q naught at point O, and that's why they will cancel each other and hence net force will be 0. Net force due to this charge will be 0. Similarly, if you observe this one, point D as well as B, so the force on a point O due to D will be attractive force, so it may be like this, attractive force. So what will happen? It will try to attract in this direction, but similar equal amount of charge, equal amount of minus 5 coulomb, and in this direction also they have kept minus 5 coulomb, so it means that equal amount of force and force will be applied in opposite direction. So similarly net force. Similarly, net force due to B and D on charge O is 0. So I hope, so net force will be 0. I hope you have understood this question. Now see this question. An electrostatic field lines is continuous curve. That is, a field line cannot have a sudden breaks. Why not? An electrostatic field line is a continuous curve because a charge experiences a continuous force when traced in an electrostatic force. And this field line cannot have a sudden break because the charge moves continuously and does not jump from one point to another. So let us try to understand that if there is a field lines like this, got it? So if a charge will move, so charge will move in a continuous way so that it won't jump from this place to this place, right? So that's why it is considered as a continuous curve. Now second part, explain why two field lines never cross each other at any points. So the thing is that if two field lines cross each other at a point, then electric field intensity will show two direction at that point, and this is not possible. For example, let us suppose there is a two, they are crossing. So if you electric field cannot have a two direction because it will either originate from positive and enter into negative. So there it cannot have a two direction, so that is impossible. So this is the best answer. This is the best way to explain this type of problem. I hope you have understood this one. Now let us solve next question. In this question it is written that 2 point charge qa, they are asking that if there is a charge qa and qb are located at a 20 centimeter apart in a vacuum, what is the electric field at a point midpoint O of the line AB joining the two charges? So let us suppose we need to find a charge, or we need to keep the charge. So let us suppose there is a charge qa and there is a charge qb, got it? And the distance between these two one is how much? Distance between these two one is 20 centimeter, and qa is equal to 3 microcoulomb and qb is equal to minus 3 microcoulomb, right? And we need to find what is the electric field at the midpoint of the line joining AB. Now electric field due to A is how much, and electric field due to B is how much? So if we need to find out, first of all, electric field due to A at a point O and electric field due to point B at a O is how much? And when we will get this, so we will, I hope you will able to find this one and solution, right? So first of all, we can go step by step. So the distance, so if you want to find electric field at this mid interval, so electric field, that is suppose electric field at a point O due to A, that is E1. If you consider E1, so E1 will be equal to Kq by R square. Kq by R square. So basically what happened? K is 1 by 4 pi epsilon naught into charge Q. Q is how much? Q is 3 microcoulomb, that is equal to 3 into 10 to the power minus 6 divided by R square. So the distance between these two one is 10 centimeter. So this is basically 10 into 10 to the power minus 2 whole square. And it is acting along which direction? So this is your plus. So what will happen? It will act along this one. It means electric field will be along OB. So electric field will be electric field will be along OB. Now Just we need to calculate is, so 9 into 10 to the power 9 into 3 into 10 to the power minus 6 divided by 10, 10 to the power minus 2. So it is how much? It will be equal to 27 into 10 to the power 9 minus 6 plus 2. So this will be how much? 27 into 10 to the power 10 to the power 5 Newton per Coulomb. So this is the electric field along OB. Now we need to find electric field along due to charge minus 3 Coulomb. So let us find electric field that is due to charge minus 3 Coulomb. So that is this one. So this will be equal to again kq by r square. So this will be probably same formula we need to use, and we will get same result, that is 27 into 10 to the power 5 Newton per Coulomb. But only thing, only what is the difference? So it will also act along this direction, right? Because it is negative charge, so field will also act along OB. So field is acting along OB. So total net electric field at a point O will be equal to E1 plus E2. Since both have same direction, so we can add on. So when you will add on, so you will become 2 into 27 into 10 to the power 5 Newton per Coulomb. So this will be finally 54 into 10 to the power 5 Newton per Coulomb acting along OB. Acting along OB. I hope you have understood this one. Now the thing is that we need to solve part 2 of this question. So the part 2 of this question is, uh, if a negative test charge of magnitude 1.5 into 10 power minus 9 Coulomb is placed at this point, so what is the force experienced by the test charge? So we need to find a force. So since we know that, so it's very easy part. So we understood that electric field, or a field electric field acting at a point O is equal to 54 into 10 to the power 5, 54 into 10 to the power 5 Newton per Coulomb, right? Now they have given the charge. When you put a charge, so how much force will be experienced by this charge? So we need to understand that what is the value of charge they have given. Test charge is 1.5 into 10 power minus 9, 1.5 into 10 to the power minus 9 Coulomb. Now the force experienced by the charge q on a test charge q is equal to F is equal to q, we know that. So this will be how much? 1.5 into 10 to the power minus 9 into 54 into 10 to the power 5. So this will be how much if you want to calculate this? So minus 9. So this will be probably approximately equal to 8.1 into 10 to the power minus 3 Newton. And this force will be along, force is directed along line OA. Force is directed along OA. Why this is so? Why this is so? See, when you observe this one, so this is your positive and this is your negative, and you are putting here positive charge, so it will get attracted in this direction and it will be repelled. So positive charge will repelled by positive charge will be repelled by positive charge and attract by negative charge. So I hope you have done this one. So next we should proceed next question. Now let us solve this problem. In this question, a system, see here, in this question, if you want to understand the question, a system has a two charge QA having a charge of this one and QB having a charge of this one, and is located at a point A 0 0 0 this one and B. So this is a three dimensions, so respectively what are the total charge and the electric dipole moment. So they have given the position of the charges. So if you want to find out truly, if you want to find out truly the position, so they have given three dimension figure. So this is, let us suppose, X, this is Y, and this is your Z axis, right? Now they have given the location in such a way that they are including only Z part. Why? If you observe properly, so see, they have given A is equal to 0, X, it means X is 0, Y 0, and minus 15 centimeter. So let us suppose there is a point A, so it should be located at this point. So this point's location is 0 0 and minus 15 centimeter, right? Now the charge at a point A, that is QA, is probably given as 2.5 into 10 to the power minus 7 Coulomb, right? Now if you want to talk about the charge B, so let us suppose there is a charge B, so which is located at a point B. So QB is equal to, they have given QB is equal to minus 2.5 into 10 to the power minus 7 Coulomb, right? And if you want to check the location, so location will be how much? So this is 0 0 plus 15 centimeter, right? So I hope you have understood this one. Now the total charge, if you want to know total charge, so how much will be there? So total charge is equal to Q at A plus Q at B, and this is equal to 2.5 into 10 to the power minus 7 minus 2.5 into 10 to the power minus 7. So this will become 0. I hope you have understood this one. Now they are asking dipole. So what is dipole? So dipole, if you want to find dipole of a charge, so dipole, because both are equal and opposite charge, so dipole will be equal to charge into distance between them. What is the distance? So if you want to find out the distance, so this itself is the distance. So this distance is how much? So this side this is 15 and this side is this 15. So distance d is itself is equal to 30 centimeter. Now we need to calculate it. So if you want to calculate it, so how to do this? So charge, any one of the charge you can take. So this is 2.5 into 10 to the power minus 7 and into the distance is how much? Distance is 30. 30 divided by 100 because it is in centimeter. So I hope you have understood this one. So this will be 7.5 into 10 to the power minus 8 Coulomb meter, right? So this is the unit. Now the direction. So very important, direction of dipole is from negative to positive, positive charge. So from here we can say that direction is along A, along A. So I hope you have understood this one. Now, now let us suppose question. Let us solve question number 1.10. Now we need to read the question before we need to solve this one, right? So electric dipole with the dipole moment of 4 into 10 power minus 9 Coulomb meter is aligned at 30 degree with the direction of the uniform electric field having a magnitude of this one. Calculate the magnitude of the torque acting on this one. So what data they have provided you, so we need to write this one. So first of all we need to find dipole moment. So that is P is equal to 4 into 10 to the power minus 9 Coulomb meter, right? Aligned with the angle theta. So the theta at which the dipole is aligned is 30 degree. When the direction of uniform electric field, they have already told you that it is a uniform electric field and it is 5 into 10 power 4 Newton per Coulomb. Calculate the magnitude of the torque. So if you depict the diagram, so let us suppose these are the parallel magnetic field, right? These are the uniform magnetic field, and now let us suppose there is a dipole. So we can put here the dipole which is making an angle of how much? 30 degree, right? Now how much? See, let us suppose there is a positive charge, there is a negative charge, anything else. So we need to find a, or it may be positive, it may be negative, it depends upon, right? So let us suppose they if you want to find a torque, so torque will be equal to P cross E. So you know this formula. So the P cross E, that is equal to PE sine theta, magnitude of PE sine theta. So magnitude of P and E. So you should put the values of a P. So P is how much? P is equal to 4 into 10 to the power minus 9 into E means 5 into 10 to the power 4 into sine 30 degree. So it will be how much? 10 into 10 to the power minus 5 Newton meter. So I hope you have understood this one. So this is the probability of answer. So thank you for watching. So this is part 2 video.